So now we're going to look a little into the simulation exercise and how to work with this, what we have a template project with some built-in simulation and how to work with it. We're going to look at some of one exercise a little, but then there are separate videos and documents for these simulation exercises, how to solve those. It's not, this exercise is not with a teaspoon, that you have to find information yourself and search a little and find out how to program it. There are programming tips and a little context and so on. But what we are going to look at now is the project itself and how to start up the simulation, or we're going to try to do that. So let's have a little look at project. When you open this template project, let's open over here. When you retrieve it, you get something like this. And in here, the program blocks, you will find some emulators, which is this simulation for the exercise that we have. There are 6 so far in here, an internal simulation, and these are organized so they are kind of called in tasks down here under program. We have got these tasks in this background task. These internal simulations are called. So you can open this and just look at it and yeah, see what it looks like. And in the program here, you should probably organize your program like this. Make folders. Folders are right-click, group. They call it a group. They could have called it a folder because this is a folder, but okay, it's a group of programs. So here's the first and low pass filter. Okay. To do this, what we need is a simulator. We need a CPU to run this on. If you have a physical CPU, feel free to use it. And if you go online or that one. But so there are 2 things. We need a PLC simulator, and it's just select the project, push this button, says start simulation. Okay, we can go online on real CPUs when we do simulation. Well, that's just the way it is. Okay, here you might not have a workspace, so you have to create a workspace, but I have a workspace with this, my solved template here, and you could do something like this. And if you don't have a CPU, you'd have to drag in a CPU, but it seems like my CPU is starting up. This, you might have to push this symbol here to power it on, because here's where you power it on and off, and here you can start it. This simulator is a little slow, but it's pretty powerful. You can see there's quite other 2 CPUs that you do test. Even these hot standby or redundant CPUs, you can do testing, software control, and so on. And now I need a program, and if I close this down, okay, let's say my TI portal has found my test CPU. It is this address. You might not have this address on the first run, and you might have to push start search too. And now I can load. If I'm lucky, I've used it before. It doesn't want to load much, because it's already, I've saved my workspace, ready for loading. Let's see what it says. Check for loading. Difference between online configuration will not be loaded, because I've loaded it and saved it before. So my CPU and workspace is up to date. So I could select load, but if I'm lucky now, I can just take cancel. And okay, it's not running. These are grayed out, so I can't select those. It's powered on. Yes. Can I select run here? No. This yellow light is the same orange LED here is the same you have on the front of your CPU, but I can't select anything run. But it seems to be under power. So let's see over here, I say online, start CPU. Here is an option. Yes, that's why I asked for it. So this is like TI Portal. If it's possible to ask a question, they are going to ask you a question and you have to answer yes or no or something like that. The reason why I selected run was because I want to switch it on. But okay, it's often nice to be able to, let's say, cancel things like that. So now it is running. So now I should be online here. Minimize that one. And now I can test selecting the CPU and say go online. And in the first exercise, it's yellow, it's all turning green here. It should be because the green, not so ripe berries here, they indicate that your program online is up to date. If I do changes here, these are going to change. And let's say here is something for the first exercise. You should use an internal function. You can see if it's online, do some scaling, yes. This is solved, so this is an input from a simulator. I'm going to look at that later on. So it's doing something. You see, it's doing something. It's live here, and I could change these values too, at least some of those. Maximum output is 100. A double click here, I can write a new value. If it's well, external fault, I don't know if it's used, then I can toggle this one if I want to. And in the compendium, there is a description over this function. But that's not what we are going to look at now for the introduction. Now we have to look at some screens here. And here is also some pre-made screens that I can operate these simulators, emulators. It's the same. Select this one. And again, start simulation. But now I'm starting an HMI simulation. So here's doing a little compile down here. So when it's done with the compiling here, and if I'm looking, it's going to open a new screen over here where I can have an online view about what's going on in this PLC, basically what is going on in my instance data blocks here. So it might take some time. It should be compiled. Your stuff. So here is some screens and stuff. Now it's doing something here. I've been thinking a little hard. And then it's going to open these screens. And if we look at the signal simulator, that was the one that we looked at over here. We can maybe go back up here. If you do program, you need more than a laptop screen with a 10-inch screen or something like that. You need two screens. This is a virtual machine that I'm using. And on my virtual machine, what I can do is choose the monitor layout. I have quite a few monitors here, so I could select. If you want to do any serious programming in any programming systems, you would need at least two monitors. So here is the low pass filter that you have to program. What I've done here too is I have something on the low pass filter, so I can enable the filter. That's something you have to program, and this time constant and sampling time, now they're all 0 because I haven't used it. And here I can simulate some signals for my filters. I can say I can enable my signal. That's just a sine signal. I can enable some deterministic noise. That's just another sinusoid. And these are the frequencies here for these. I can enable some random noise too for this system. And here too, in these, if I select in the background here, it's I'm thinking a little here. Yeah. Under the simulators, there's signal simulation. There's a function block here that is signal emulator, and here in this instance data block, which is then inputs and outputs for the simulator, you could also go online here and see these are true, and that's what its output here. Maybe my let's see, my, at least here I have a sinusoid, an amplitude. You should be able to change these 10 by 10 and enter. You should get a little noise over here too. And you have to enable the filter that I have. If you want to do some filter, you need a time constant, maybe 1. Enter. Sampling type 20 a second. That was maybe not so fast. 0.002, 20 milliseconds I think it is, and so on. It doesn't seem like this one is at least I can enable the signal. I can enable the noise. Seem like it's doing much my simulator over here, but here you can see what you have should be filtered, what you're filtering to. So this is the way these simulators work. Yes. So that was one, and then we have a simulator for valve that if I'm looking to, maybe I should be able to open it. Here's a control signal and the valve should open. And when it's open, maybe I get an error, but at least I get something flow into my reservoir. And here is something you can manipulate the valve. There's a tank too that we do control. You can, this is the controller, so I can set an automatic mode and set some set point here and enable the tank. Maybe I could say something, how much do I want? 50 in the tank. Okay, so maybe something is going to happen here. And the tank is going to fill slowly, so I can do some control here. And here is not the parameters for my controller. This is a PID controller, and I can add some consumption of 2% or something. So, and here are some curves for that. Then we have got a transport simulator. Maybe enable feed and enable my sorting here, and if I'm lucky it's going to sort here. The blue ones I program to go to this transport, and the green one, if you're lucky, is going to go over here. And if I get one of these other ones that I don't detect, just in no detector, they should just pass through that, doing nothing. And here too I should be able to disable this, and you should remember the queue, so the green should still be ejected here and the blue should still be ejected here. Some reset. So this is the sorting program. Then there is a traffic light simulator, control the traffic light in here. So I just started up, so it's red in both directions, and if I'm lucky, I'm going to start. I think this is the preferred direction, so now I've got traffic here. So if I want to cross as a pedestrian here now, they have green, so I probably have red, and they have green, but I want to cross. Accepted my command, and this is a light that should go out when I get a green here. Okay, I get green, so my request is acknowledged, and then it stops, it's flashing, and so on. So this is just the way it is, and of course this is really fast. And then the last one here is not for control, that's just for fun. It's a Morse decoder. So I don't know if it's working. Let's say transmit text, yes. This is ASCII, that was SOS, and maybe I could do something else here. I think maybe I could write something here. AAA should work. Works only on capital letters. Morse here. I should probably have. I would probably have to push enter here. It's 2 and then AAA and enter. I'm lucky now. Maybe I should get something else. The A's here I don't get because they are lowercase letters, but I should at least get the AA and 1, 2, 3. And it's slow. And in the simulator, you can increase the speed here of the program so it can write faster. So this is a decoder which is in the project. And this one, the encoder, the Morse encoder, you have to write yourself. So which is an assignment over here. And here is the signal simulator. I probably have to look a little at that one and get the noise on here, or else my filter is active. You can see the filter signal is lagging. The red one is the one that's not filtered, and yeah, the other color here is the filter, so it's lagging, so it's working a little. 0.1 hertz. It might also be a little bit my sampling time in my program. Yeah, we added 0.5, and that is something happening over here. Not much. And my random noise. Let's say if I increase the amplitude to 20. Is something working here? Nah, I don't. It doesn't seem like it adds up the noise here or something. But at least my signal is working. It's a sinusoid, and yeah, minimum and maximum output. But that is in the exercise, and you can play a little around with this. And this part will not be here in the template project, but I've just made this, and you could of course make this if you have ample time to do so. Okay, yeah, so this was just an introduction to the simulation exercise. We looked at one exercise, it didn't quite work to this signal simulation. I will probably have to look a little at it and get it to work in a template project, or maybe you could have a look at it and see why it's not working. Yeah, and we looked through all these emulators that you have to use in these exercises. There are 6 exercises in here, and you should work on them, and then there would be a suggested solution afterwards to how you could program this, and then maybe also a little testing and so on the simulator and the programs that I have written as a suggestion. So as a solution. There are a lot of ways to do programming, and nothing is right and nothing is wrong as long as it is robust. It's important that your program is robust.